Hi guys, and welcome to our module solutions for the 2021 Northern Hemisphere Paper 1 exam, Further Maths exam. Don't forget that. My name is Maths Guru. Welcome to this video. Hopefully it's going to be useful to you. I'm going to work through all the solutions, and I know you guys only have to do 2, so please give me some love and some shout outs and some likes for this video, just so that I haven't sat here for 47 hours for nothing. All right, we're going to work through question by question. Hopefully it's helpful. You'll see the question numbers come below, so you can zip through and scan and actually find the questions you're useful to, or head over to mathsguru.com where you can actually do the questions and then see the worked solutions, question by questions. Oh my God, how helpful is that? Let's start with our first module, matrices. The matrix expression is equal to, all right, so question number 1. So we're going to add them together. Now, when we add matrices together, the order all has to be the same. It is. So 2 plus 2 plus 4 gives me 8. Take away 8 is going to give me 0 in a corner. Well, the first things first, I've got to end up with a 4 by 4 matrix. Rubbish, rubbish. Rubbish, it's got to be D and E. In many cases, you can always discount 2. All right, so got to be a 0, that is a 0. All right, next one. So 6 plus 6 is 12, 24, but we've taken away 24, would be 0 again. 4 plus 4 is 8, plus 8 is 16. Take away 16 is 0. So either of those can happen, all right? And in many cases, you probably would have been quicker to have just tested that bottom right value. All right, I didn't need to do all of this because they're the same. So look for the differences in the multiple choice. 1 plus 1 is 2. 4, but take away 2 gives me 2. And there we go. E is my correct answer. Consider the following 4 matrices. How many of these matrices are diagonal matrices? Okay, so I'm just going to quote this. A square matrix is called a diagonal matrix if all of the elements of the leading diagonal are 0. So all of the elements of a leading diagonal must be 0. The elements on the leading diagonal may or may not be 0. So a leading diagonal is basically this, and this, and this, and this. So remember, it says there that all of the elements off the leading diagonal are 0. So basically, it would appear that only this one is. So how many of these matrices are diagonal? I'm going to go for B, 1 mark. The matrix equation, that has a unique solution for x and y. Which one of the following matrix equations has the same unique solution for x and y? Okay. Having set up now my calculator, that I'm going to solve it to find the solutions of x and y. All right, so you can just put those in, find the inverse of that matrix. Gives me a value of x, weirdly, as 3.4 and y as 0.7. Now, how am I then going to test these values? Well, trial and error, I suppose, because I can't think of another way of doing this one without doing trial and error, which seems silly for question number 3. I feel like I'm missing something quite important. But let's test A. And all I'm going to do is I'm going to put in a matrix, and I'm going to put in 2 minus 4. What's the value there? 4 and 2. And then I'm going to put in this matrix here, copy that one down, hit enter. Does it give me 4 and 15? No, it does not. So A is not my correct answer. So let's now copy that one down again. And this time we're going to put 2 minus 4, 4, 2, but they've swapped the values of x and y. So that's going to be 3.4, and that's going to be 0.7. Hit enter. Definitely not. That's not what comes out. C. Let's copy it down again. This is going to be 2. They've swapped the values. So 2, 4, minus 4, 2, y and x, hit enter. Gives me 15 and 4. Nope, that's not the one we are looking for. So again, ka-ching. Oh, they've swapped my values of x and y around. I'm actually going to get rid of that. And let's copy the one down with my correct x and y values. And let's see what they've got there. So they've got 4. Oi, 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 oi. Be all right if I could use my... Hello, no, 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 no. Oh, come on. 4. 2. Oh, hello, not times. Minus 16 and 8. Gives me 15 and 16. D is my correct answer. Just because I don't want to be tricked by this, I'm just going to do, let's just copy that one down, x and y. So I've got minus 4, 2, 2 and 4. 4. Ka-ching, 4 and 15, not right. There we go. Now, if there's another way of doing this, please let me know. I'm always happy to learn, because I looked at that question, I was like, poof, okay, but trial and error. Some of these questions do actually take longer. Matrix M1 is the 5 by 1 column matrix. A second 5 by 1 column matrix M2 contains the same elements as M1, but the elements are ordered. So we ended up with M2 is equal to, ordered with the largest value at the top, so that would become 25, 15, 12, 9, and 3. P is a permutation matrix. Okay, so what that's going to do is swap the values around. So 25 was the third number and it's moved to the first number. 15 was the fourth number moved to the second. 12 was the first number moved to the third. So if we look at this, this value here, when we multiply it, that is going to move my third value to the first, right? So that value there, because it's the third in the first row, is going to move the third thing to the first. That's what we wanted. So anything without a 1 in that value there is going to go. Anything with a 3, 4, 1, 5, or 2, rubbish. Permutation matrices just have 1s and 0s. Okay, so our second number came from the fourth. So our second number has to be a 1 in the 4. And in fact, that is the only one that's possible. We'll just check. Our third number comes from the first. So there we go. Our third number was first, and that's that one there. Our third number was first, and so we go on. I love permutation matrices. All right, so C is my correct answer. The factory employs the same number of workers each day. The workers are allocated to work in either the green building or the white building. The worker may be allocated to work in a different building from day to day, shown in the transition matrix. All right, so again, we got this day and next day, and we know that 52% of the people will stay where they are, okay, if they're green. The green building must have 36 workers each day. Each day, the number of workers in the white building will be. So we now know that 36 workers must stay or must be in the building each day. So when we go from one day to the next, 52% of them are going to stay. So if I work out 52% of 36, that's going to tell me how many stay. So 52 divided by 100 times by 36 gives me 18.72. They couldn't have made that any more disgusting if they tried, really, could they? So let's just say that is 19 people. So 19 people are going to stay there, which means that we must get 36 minus 19. 36 minus 19 gives me 17 people must change from W to G. All right, so 17 people must go from W to G. Now that's that value there. So 24% of those people have to equal 17. So 24% of the people in W must equal 17. So I now know that 0.24 times W equals 17. So if I now do 17 and I divide that by 0.24, it's going to give me 71. All right, so 71 people. So W must have 71 people in. Well, that's not an option, so it must be 72 as my correct answer. Question number 6. 4 families visit an amusement park. At this amusement park there are 3 rides: a roller coaster, a Ferris wheel and go-karts. Each ride has a different ticket price for adults and for children. The number of tickets that each family will pay shown in table 1. Okie dokie, thank you very much. The data in table 1 can be converted into a 4 by 6 matrix V. So V is a 4 by 6 matrix. Table 2, the ticket prices are shown. The data in table 2 can be converted into matrix W. So W is a row 2 by 3. The data in table 2 can be converted into a matrix where that one is there. Let's try that one again. Awesome. So what is that? 1, 2, 3, 4, 5, 6 by 2. One adult to ride the roller coaster is RC, is the price for one child to ride the roller coaster. The matrix product V times W. So if I now look at V times W, I'm going to end up with a 4 by 6 multiplied by 6 by 2. Now the reason I'm working this out, A, is it possible? Yes. B, what will my matrix be? So it'll be 4 by 2. So my resulting matrix will be a 4 by 2. So 1, 2, 3, 4 rows by 2 columns. Okie dokie. So it's going to have 1, 2, 3, 4, 5, 6, 7, 8 values. And again, when we look at matrix V, it's going to be the family. All right. So when we look at multiplying this, just looking at that first row, for example, it's for family 1, and then it's roller coaster, Ferris wheel. So there's a roller coaster, Ferris wheel, and go-karts. All right, here we go. So the elements in matrix L show the total cost of. So we are going to be doing, for that very first row, which will give me this number here, we are going to be doing family 1 for adults. So that is going to give me, that one there is going to be family 1, because that's the row we're doing, and we're multiplying it by the adult cost. So we're going to have the adult of family 1. So the adults of family 1. The next time we do it, when we multiply the next one, we're going to do that times the children. So that next one would be family 1 children. This then would be family 2 adults, family 2 children, family 3 adults, family 3 children, and so on. Okay, so what is it going to get? The matrix, the elements in matrix L show the total cost. So the elements, I don't want to know each value. All tickets for each family, no. All adult tickets and all child tickets at the amusement park. The elements will give me all adult tickets and all child tickets, no. All adult tickets and all child tickets for each family, that's looking likely. All tickets for each of the 3 rides, nope. All adult tickets and all child tickets for each of the 3 rides, no. So I'm going to go C as my correct answer. Okay, question 7. Each day, all employees of a large company will work for at least one location, L1, L2, L3, L4. The table below shows the number of employees at each location every Monday. Okay. The transition diagram below shows the change in the number of employees at from day to day. Lovely. On which one of the following statements is true? Right, so what I did was, I wasn't actually that interested in the number of people who were there, just whether there were people there. So on Monday, we know there are people there. So assuming they all change Monday night, because that's messing with my head, then Tuesday, so they change Monday night. What happens? Well, first things first, we know that and that means that all of the people, 0.7, 0.3, everyone from L4 will have gone. So Tuesday morning, there will be no one at L4. So there's no one at L4. But what about the rest? Well, L3 people will stay because of that loop, while L1 will have got rid of all the people. It will actually have gained people from L2 who are fed into. So I think on Tuesday, the only people who don't have anyone will be L2. Now, that's not an option, and that's not an option, so we're working our way down there now. So if we now look at Wednesday, all right, so everyone now is moving overnight again. L2 didn't have anybody gain. So L2 didn't gain anybody. So overnight, L2 will lose everybody, and there will be no one working at L2 on Wednesday. So L2 would have lost everyone on Wednesday, but L1 will have gained the people who were at L2 overnight, and likewise L3 will have gained overnight. L4 will still have no one, and so as far as I'm concerned, if we look at Wednesday, on Wednesday there will be no employees location. Nope, on Wednesday there will be no employees at location L2 and L4. I reckon D is the right answer. On Thursday there will be no employees at locations L1, L2 and L4 only. That's not true. Because L2 didn't get any, and L2's losing, they would have all gone to L1 on Wednesday, and by Thursday L1 would have had none because they would have gone to L3, and so actually L1, L2 and L4 on Thursday, so that is a no. I have sat here with numerous pieces of paper trying to get my head around this question, and in the end, the amount of time I actually put into all of this was just crazy. So my advice, to be brutally honest with you, is to put each of those in, add and square the result and see what comes out. It was so much quicker than doing it by hand, and even now I'm a bit like, I don't like the idea of this question at all. I'm sure it's a lot easier, and one day I will update the solution on mathsguru.com. But the correct answer actually turns out to be A. All right, and again, I just put that into my calculator and added it to the square of itself Unfortunately, I've deleted it. I've probably got it still here. Let me just show you. I think I've got it in here. There you go. So there was my part A. No, it wasn't, because actually I thought, oh, maybe it's part C. So I'm just going to copy that down. Change the numbers, he says quickly. So 0, yeah, put that as a 1. 0, then we've got 2 1s. We've got, that makes that one a 0. Whoops. 0 0 1, and that's 1 0 0 0. So make that D. All right. He says, let's just put ANS. We'll store that in D because I'm not convinced that's D. And I'm going to do D plus D squared. And that, in fact, gives me the correct answer. I'm fairly sure. 1, 2, 2, 1. So much easier than faffing around with the rest of this. Okie dokie, ready? Let's get going. Good networks and decision mathematics. Question 1. For a connected graph with 4 vertices and 4 edges. 4 vertices means 4 corners. 4 edges, join them together. The sum of the degree of the vertices. All right, so that has degree 2, degree 2, degree 2, and degree 2. Fairly sure that therefore adding all those together will give me 8. Which one of the following graphs has an Eulerian circuit? Right, an Eulerian circuit. I am going to refer to my notes. Suggest that for that to be true, it has to be connected, and all vertices has vertices that all have an even degree. Okay, so an even degree. Well, that has 1 degree, so it can't be A. Let's see, what about this one? That's got 2, 4, and 4, so they all have an even degree. Awesome. Let's do this one. 3, 1, 2, 3, so that's going to be a no, that's going to be a no. Let's see whether we can discount others. 1, 2, 3, that's going to be a no. That's got 2, 1, 2, 3, 4, 5, that's going to be a no. And so, assuming that we have got 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, B will be my correct answer. And remember, a loop here has 1 edge, but it's got 2 degrees. Okay, so just be careful there. All right, the sport of basketball has 5 player positions: centre, power forward, small forward, point guard, and shooting guard. 5 friends, A, B, C, D, and E. I'm not reading their names. Play together in a team. The bipartite graph shows at which position each of the 5 friends can play. Based on the bipartite graph, which one of the following allocations is not possible? Now, when I did this, I quite literally went through A, B, C, D. I can't see any other way of doing this one than by trial and error. So if we have a look, can Ange be a power forward? Yes. Can Ben be a small forward? Yes, because there's a line going there. Can Charlie be a centre? Yes. Can Doris be a point guard? Yes. And can Esther be a shooting guard? Yes. So that one is absolutely possible. So A is not my correct answer. In fact, what I ended up doing was getting all the way down to E. And I think it's Charlie small forward. And if we have a look here, Charlie cannot and does not have a connection to small forward, which means that E is my incorrect answer. I think this is a bit of a trick question, right? Because for it to have faces, we've got to actually not have any crosses. It's got to be planar. So I'm going to first things first put that over there. That's going to get rid of that cross there and that cross there. And then I'm going to take this one and I'm going to bring that over here. All right, so what does that give me? That would give me 1, 2, 3. So that would give me the inside triangle. And then I'd have a connection to here, a connection to here, and a connection here. So that's going to connect around there. And this is going to connect around here. So I should have 1, 2, 3, 4, 5, 6 dots. I do indeed. And so now, if I'm going to look at the faces, there's 1, 2, and 3. I reckon A is my correct answer. Okay, so the minute it talks about the word faces, we'd have to assume it was planar, which means we have to turn it around. Aisha works as a sales representative. The network below shows the roads that Aisha could use to travel between her clients. Aisha's clients are represented by the vertices labelled A to J. The edges in the network represent the roads, and the numbers on the edges the distance in kilometres. Aisha needs to travel from client A to client J. Using Dijkstra's algorithm, she finds that. Now, this is a bit of a trick. I don't think they actually wanted you to do Dijkstra's algorithm. Because Dijkstra's algorithm is used to find the shortest path, not the critical path. So automatically, I'm going to turn around and say A, B, and E are not my right answers, right? I think Dijkstra's algorithm there was literally there to try and point you in the idea that we were looking for the shortest path. Now we've got to try and find the shortest path from A to J. And I'm going to go 24, 23. So what does that give me? 47. Well, that's not one of my answers. So that's no use to me. Is there another one we can choose? Yep, let's go 6. Oops, let's highlight, not rub. 6, 15, 23. 6, 15 is, what would that be? 21. 15, 16, 17, 18, 19, 20, 21, and 44. All right, well, there we go. So as far as I'm concerned, because I have found a shortest path to 44 kilometers, then I am going to circle C as my correct answer and move on. I feel sorry for anybody who actually sat there and did this by using Dijkstra's algorithm. Whoosh. Question 6. The vertices of the network below represent 9 communication towers. The edges of the vertices are graphs. Fiber optic cables that connect the communication towers. The numbers on the edges show the length in kilometers of fiber optic cable between the communication towers. Okay. The minimum length of the fiber optic cable that is required to connect the 9 communication towers is 28 kilometers, except when? Okay. So let's assume that I'm going to start here. I'm going to start here and I've got 3, 3, 3. Okay. So now the question is, that below looks of things is always going to be part of my diagram. And what I then did was just work my way around them. And I made m equals 1 and n equals 5. So now what does that mean? Well, that would be my next shortest. Then 4, then 5, then 4. And I've always got that one over there, then 5 to connect those together. All right, so there we go. So that's the values when m is 1 and n is 5. Now again, there may be other ways of doing this. By all means, let me know. But 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 19, 24, and 28. All right, so that one there is 28. So A isn't my correct answer. So now what I'm going to do is just rub out these for the moment. All right, and it's relatively quick and easy. He says, lol. All right. What are we going to do now? Rub out 5 and the 1, and let's put in the new values. M is 2, and n is 5 again. Didn't have to rub that one out. All right, let's see what happens now. So now 2 again, 4, 5, 4, and 5, I think. There we go. So that should be my shortest again. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 20. That would be 29. So I'm actually going to posit at the moment that B is my correct answer. I'm just going to test one more. We'll see whether 2 and 4 make any difference. So we'd make that 4. Well, actually, if we make that 4, I already know that because this was 29, and I've taken 1 off, that would be 28. So that's not an answer. M equals 3. And m equals 3 and n equals 3. 3 and 3. And I'm fairly sure, once again, that won't change anything. So 5, 8, 9, 10, 11, 14, 17, 21, and 7 is 28. And again, so I'm fairly sure there. We could check the last one, but I'm fairly sure B would be my correct answer. Okay, so question number 7, I've already done a little bit of the pre-work for this question just to try and make life a little bit easier. So that was my activities, which I turned into this rather stunning activity network here. He says, zooming in just a little bit. Now, I was going to put all the scanning numbers in, but I thought, well, some people like to see how this is done, and I do it by putting the numbers on the edges, not on the vertices. So I now know that that's going to be a 0. So I get to here, and I know that both of these have to be 9s. The reason they're both 9 is because that is the earliest time A is going to finish. A is going to take 9, all right? So 0 here is my start, 9, and as soon as I have a branch off going that way, I put 9 into both of those, all right? So this one here gets to 9 plus 5, which is 9, 10, 11, 12, 13, 14, which means, again, because I've got a branch off here, that is 14, and that is 14. Awesome, so far so good. Then we get to here, and I'm like, right, well, I've now got a choice. because I've got two arrows coming into the same point, and that's got to be a choice. So I'm now going to do, well, 9 plus the 7 of B gives me 16, so that's one of my choices there, and a 14 plus the 3 gives me the 17. Because I'm going this way, I'm using the largest numbers, that's going to be 17. So what I'm saying is here, that now has to be 17, and G also have to be 17, because they're branching off of there. So they both have to have that earliest start time. What I do here, we get to here now, and I've got a choice again. So the 17 of G plus the 4 is 21. I've got 6 plus the 14, which gives me 20. I've got to choose the largest one. So again, that one there will be 21. And K here will be 21 as well, because they're both coming off of that value there. Right, okay, so 21 and 21. 21 plus 2 gives me 23, so it has to be 23. That gets me to there. 23 plus the 5 gives me 28. Yep. And 28 plus the 5 gives me 28, 29, 30, 31, 32, 33. So there is a choice of 33 there because it's coming in. But also I've got the 21 plus the 7, which gives me 28. So I would have to have 33 there. And now I'm going to backwards track. So we know that this one here is going to start at 33. 33 minus the 5 gives me 28. 33 minus 7 gives me 26. All right, so there's 26 going backwards. 21, what did that say now? I can't remember. God, my handwriting is shocking. 33 minus 5 gives me 28. So 28 minus the 5 gives me the 23. And I keep checking this to make sure I keep getting my, what do I keep getting? My critical path. Okay, so now I'm going to go down H. 23 minus 2 gives me the 21. I've now got a choice because I've got two things coming into that point there. I've got 21 or 26. I choose the smallest value. So it's going to be 21. So 21 minus the 4 gives me the 17. 21 minus the 6 gives me 15. That's right, yep. All right, so again, I'm now at this point here, which was 23. Minus 4 gives me 19. And then I get to here and I've got a choice between the 19 and the 17 from the F and the G. 19 to 17, so what I choose? I choose the smallest number. So that's now going to give me 17 here. 17 minus 7 gives me 10. Right, 17, yep. And 17 minus 3 gives me the 14. And now I've got a choice coming into here of the 14 or the 15. I choose the 14. 14 minus 9 gives me, sorry, 14 minus 5 gives me the 9. So it's 14, and then I am now at this point here. So the smallest between 9 and 10, which is 9, and 9 minus 9 is 0. There we go. So ladies and gentlemen, that's my forward scanning and backward scanning. And what I'm now going to do is highlight my critical path. He says H, I, and J. So 1, 2, 3, 4, 5, 6, and 7 of those remain on the critical path. And so to complete the project in the minimum time, the number of activities that cannot be delayed, that's just the critical path, would be 7. So I reckon D is my correct answer for that question. Now, moving on to this question, again, God, these questions took forever. And again, if you have a better way of doing it, please, please, please let me know. What I did was put on all of my boxes and I did the forward and backward scanning. And did that take some time? I'm going to do it now. Okay, so there we go. There's the forwards and backwards scanning already now completed. And what we notice is we have our critical path, but that's not actually massively important at this moment in time. What we know when we have the original building is going to take 28 weeks to complete. Now, what they say is activity D is no longer required and is removed. Actually, I'm going to highlight my critical path because I did it for when I did the solutions a moment ago. All right, so that was my critical path. That journey there gave me 28. Now, what they're going to do is they're actually saying, well, we're now going to remove D. So that there just disappears. It's gone. Goodbye, farewell. And what they say now is that another activity M, having a duration of 2 hours with an earlier start time of 17 hours. Now, what that meant was to go back through and redo all of my forwards and backwards scanning. Did it? Well, sort of yes and no. What I wanted to do was try and find out where I could get to in 17 hours. And what I mean by that is I now start working my way around this diagram in different ways. So I went, well, if I go from C to H, that's 14 hours. So that's no good to me. What about if I go there to there? There is 17 hours, surprisingly. All right, now the earliest start time of 17 hours would then suggest to me that M would have to start at this point here. So let's just delete my two orange lines there. So I'm going to posit that M would start there. And because it's going to be 2 hours, K isn't going to be any different. I then suggested that that was going to connect directly to there. So that is now M, which is a length of 2, and we know it has an earlier start time of 17. Now, how does that help me with the rest of my diagram? Well, what I did was I said, well, okay, if that has an earlier start time of 17, then by the time I get to here, I've got 17 plus the 2, which gives me the 19. So is my critical path going to change? Well, that's going to give me 19 to go 16, 17, 18, 19. So if I go B to G to M, that's 19. But there are other routes to get to M that we have to check. So we've got 5 and 7 is 12, and that's 20. So as it turns out, my critical path is now going to go A, E, I, unless we can find another route. So 4, 14, 16. So as far as I'm concerned now, my critical path has changed. So that, to get to this point here, is now going to be 20. So I'm now going to use that value. So that's going to be 20 plus 4, which is going to be 24, 25, 26, 27. So now I know to get all the way along here is actually going to take 27 to be able to do it by adding in that M of 2 there. That means that the activity of Druid has an early start of 17 and a minimum completion time. Right. Now I'm just going to check the backwards scanning to make sure that it does actually have a latest start time of 18. Because otherwise, the only other place it can fit is I'd have to join it in here somewhere. But that doesn't really make a lot of sense. And when I played with it earlier, it wasn't right. So if I now go backwards with 27, 27 minus 3 gives me 24. So that's going to be 24 minus 4 gives me the 20. So that means that this value here would now become 20, which basically means that 20 minus 2 gives me the 18 in there. And so I'm fairly confident that that's where M is going to be. So having that suggests that because I'm putting that D out and M in, the completion time is going to be 1 hour less. B is the answer I believe it's going to be. All right, now we're on module 3, geometry and measurement. Right, a store. Let's read, shall we? A stove has one circular burner. Thank you very much. There is my circular burner. The burner has a radius of 11 centimeters. The area of the top of this burner in square centimeters is closest to. We know the area of a circle is pi times radius squared. That's all I need. Let's fire up my calculator and let's do pi. And we're going to do times 11 squared, which gives me 380.133. So D would be my correct answer. Let's write that there for 380.133 centimeters squared. All right. Question 2. The length and width of a rectangular photograph will increase by a linear scale factor of K equals 4. The area of this photograph has increased by. When you multiply areas or when you make your lengths bigger, you work out your scale factor. All right, so a linear scale factor of K equals 4 means that I am now going to do 4 squared, because you take that linear scale factor and you square it, and that will give you by how much your area has increased. So 4 squared is 16. D is the correct answer. A rectangular swimming pool is enclosed by a brick wall on one side. Thank you very much. So let's just check there. Oh. So there is my brick wall, yep, on one side and fence along the other 3 sides. The pool is 8 meters long and 5 meters wide. Okay, the fence is 1.2 meters from the pool on each side. Thank you. The area between the pool and the fence will be concreted as shown in the diagram below. The total area that will be concreted is, okie dokie. So first things first, what I'm actually going to do is I'm going to find the area of the large, this outside, what am I going to call that? The outside square, all right? Or rectangle actually, to make that correct. So what is it? We know that the inside pool is 8 meters, but I've got to add on 1.2 and 1.2. So 8 plus 1.2 plus 1.2. Again, I'm doing this so I don't make any silly calculation errors, right? That's 10.4. The height of the pool is 5, but I'm only adding on one of those 1.2s. Oops, 6.2. All right, and I think that was the trick of the question. So if I now do 10.4 times 6.2, I get 64.48 square meters. That's the outside. And then all I need to do now is subtract the area of my inside pool, which is 8 times 5 or 40. So if I do 64.48 and I take away 40, so minus 40, and again, see what I did there? Muppet. Minus 40 gives me 24.48. B is my correct answer. Points A, B, and C are located around a lake as shown in the diagram below. All right, point A is directly north of B. Interesting, good to know. Point C is 46 meters from point A. So we now know that that's 46 on a bearing of 133 degrees. And again, we need to make sure that we put our bearing point in the right place because it is from point A. So there's point A, that there is 133 degrees. Point C is 35 meters from B on a bearing of 74 degrees. So that there is 74 degrees. The shortest distance from point the shortest distance from point A to point B in meters can be found by evaluating. Ooh, long word. So this is a sine rule question because that's what we want x. Now what do we know then? Well, using the sine rule, we have the side we want, and do we know its opposite angle there? We don't, but can we find it? I should Coco. So I can find this angle here, that angle inside the triangle, because we know that that's a straight line. So 118 minus 133 gives me 47 degrees. That angle there is 47 degrees, which now means that because I've got the other 2 angles in that triangle, I can do 180 minus 47 minus 74 gives me 59 degrees. There we go. So there's my 59 degrees. So using the sine rule, I can have x on the sine of 57 is equal to, and then what do we have here? What other side length do I know? 35 on its opposite angle, which is 47, which is the sine of 47. So rearranging this, I can now put the x is equal to 35 times the sine of 57 divided by the sine of 47 degrees. Let's see, is that one of my options? 35. Right, so 35, well, anything with a 46 in is a no, so let's cut those down. Sine, did I say 57 or 59? I can't even read my own handwriting. 59? 59. So 35 sine 59, so it can't be that one. And then I've got to do is divide it by sine of 47, which gives me A as my correct answer. And again, sorry about that, guys, I can't read my own handwriting. 59. All right, so a square-based pyramid is shown below, and it is telling me one angle. Now, it's weird that it's telling me that angle because it's 60 degrees. Now, basically, that suggests to me that each of these triangles here, and they've put it interestingly here, so we now know that this triangle here, if it's 60 degrees inside that angle, and those 2 angles there must be exactly the same, they've got to be 60 as well. So this is an equilateral triangle. What does that tell you? That all the sides are the same length. Now, how was that important to me? Well, I was just thinking to myself, if I know this length here, then I can work out the height of my triangle using Pythagoras. Yeah, not a particularly nice question, but it's certainly a way to do it. So, because it's an equilateral triangle, I know that that slant length there is actually 15. So, what does that tell me? Well, I've got a right angle triangle here. So h is what I'm trying to find, and I know that's 15. The angle is irrelevant to me now. There's nothing I can do about it, because really I've now got to find this bottom width here, which just happens to be half of the diagonal of that whole triangle. So again, we have a pyramid, sorry, there we go. We know that's 15, and that's 15. So what can I do? Can I find half this length? I should Coco. So we're going to do this whole length here is going to be 15 squared plus 15 squared and the square root of it, which we only want half of it. So I'm actually going to divide that all by 2. Yuck. Like this so far? Not a lot. No, me either. Okay, so if we do 15 squared, 225 times that by 2, 450. So this value here is going to be the square root of 450, all divided by 2. Happy with that so far? Awesome. So now we know that 15 squared is equal to h squared plus root 450 on 2, all squared. Now that's nice because that gets rid of that square root sign for me. So we already said that 15 squared was 225. Equals h squared plus 450 on 4. So I'm going to do 225. I'm going to minus, oops, wrong one. I'm going to minus 450 on 4, hit enter. So that means that h squared is equal to 112.5. So if I now square root that, square root my answer, I'm going to get 10.6 to 1 decimal place. So I'm going to suggest that B is my correct answer. Question 6. The shortest great circle distance between the Great Pyramid of Giza and the North Pole is approximately 6702. So great circle. So I had one of these questions before in a previous exam. So here is my North Pole, and let's say Giza is here for the moment. I'm just going to choose that as my great circle. And it knows that that distance is 6702 kilometers. Assume that the Earth's radius is 6,400. Now again, that gives me that that's there 6400, and that's 6400 as well. Ha ha ha! The latitude of the Great Pyramid of Giza is right. So what they're really asking me to do now is find that angle there, and then be careful because I think there's a trick here. So we know we've got an arc length. So we know the arc length is equal to pi r theta on 180 degrees. So there we go. We know the arc length is 6702 is equal to pi times the radius of 6,400 times theta on 180. So let's try whether we can find theta. 6702. Now again, you guys may just put this in and do solve on your calculator, which is fine. 6702 times 180. I'm going to divide that by, open some brackets, pi times 6400 gives me 60 degrees. There we go. So that actually, theta is, as far as I'm concerned, 60 degrees. Now, it wants the latitude. And if you remember, the latitude is taken with respect to the equator. So if we know that this angle here is 60 degrees, it means that that angle there must be 30 degrees. And so because it's above, that's going to be 30 degrees north. And I would say that A would be my correct answer. A triangle KLM is shown in the diagram below. Point J is located on the side of KM. Awesome. So that's just telling me that there's point J. Hello, point J. The length of the side KL is 20. The length of the sides JL and LM are 14. So I'm actually just going to write that one on there as well. 14. The angle JLM. So JLM. Sounds like a pop group, doesn't it? JLM is closest to. All right. How are we going to work this one out? Okay. So I can see here that I have a sine rule question. Now, the reason I know it's a sine rule question is there is my big, I look at that big triangle there. And the reason being is if I can find this angle in here, then that angle there is exactly the same, which means I can find that top angle there. And this is certainly one way of doing it. There may be other ways of doing it. Now, the sine rule states that if I have, the sine rule states that I can find this angle here if I know that opposite side, and I have an angle with another opposite side, which I do. So I've got the 30 degrees and the 14. So I now know that 14 divided by the sine of 30 is equal to, let's call it theta, that angle there is theta, divided by, no, let's try that one again, is going to be 20 divided by the sine of theta. All right, so swapping it around again, I get sine theta is going to be equal to 20 times the sine of 30 divided by 14. So that's going to give me the size of that angle. So let's put that in my CAS calculator. So let's do that. So 20 times, and make sure that your calculator is in degrees mode, guys. I say this over and over again. 30, I'm trying to do this left-handed, which isn't helpful, gives me that value, and that's sine theta. So what I now need to do is I need to inverse sine it, or shift sine my answer to give me 45 point whatever it is. So theta there is 45.5847. Now I'm not going to do anything with that at the moment. I'm not going to round it because I'll do that later. So we know that that angle is theta. This angle there is also the same. The reason being is that these are isosceles triangles, which means those two corner angles are the same. So if I times that by 2, that gives me both of those bottom ones, and I do 180 minus my previous answer is going to give me 88.8. So because it wants my closest value, scrolling up so my big head's not in the way, that would give me 89 degrees. All right, so question number 8, I think is one of the stupidest questions I've ever done. Again, hours now spent doing this, and I'm really not convinced about my answer. So if you think of a different way of doing it, let me know. But the point of it is, they are going to a wedding. Is it a wedding? They're going to a wedding. So Harry, Josh, and Michael. So just to let you know what my diagram here, there's Harry, there's Josh, and there's Michael. They're going to this wedding, and they're going to leave at various times, local time, and they've got various journeys. Okay, so this is where they're going to try and go, this one, this value here. Now it would make sense that Michael is going to fly that way. So if we imagine 0 as the Greenwich meridian, and then Michael is going to make sense to just fly directly to P, but he's going against time, all right? So he's actually going to go backwards in time. Because I know that we've got those, so 150 minus 118 gives me 32. Divide that by 15 gives me roughly 2 hours of time difference. So that means he's going to take 2 hours off of his travel time, if that sort of makes sense. Now, again, I don't work it out that way. So if I look at Michael, and I'm going to highlight it because this did my head in earlier, he's leaving Monday at 5 p.m. His flight time is 8 hours. Right, so he's going to leave 8 hours. So if we look at his local time, Monday at 5 p.m, 5, 6, 7, 8, 9, 10, 11, 12, 1 a.m. So his local time would be Tuesday at 1 a.m. But he's then got to knock off the 2 hours he's gone backwards in time. So I reckon he's going to arrive on Monday at 11 p.m. All right, so there's Michael. I think he's going to arrive Monday at 11 p.m. Rubbing this out again because trying to do these did my head in. And what have we got now? We have, let's deal with Harry. So Harry is going to take 12 hours to fly from 140 degrees. Now, it makes absolutely no sense, particularly with those travel times, for Harry to fly this way. So what I think the question is doing, and I think it's a trick, is he's actually going to fly through the international dateline. And by that, I mean he's going to fly through 180 degrees. Because what happens is, as soon as he does that, he effectively loses a day. All right, so he effectively goes back one day when he crosses the international dateline. And if you've been on a plane and the pilot's told you, like, oh, well, you now have to knock a day off, then you knock a day off. All right, so what that now means is he's effectively on the international dateline. 175 degrees is roughly speaking there. So what is it? Who are we dealing with? We're dealing with Harry. So actually he's got 140 degrees. So what that means is he's got to fly to the international dateline, which is 40 degrees. So 180 minus 140 is 40 degrees. Divide that by 15 gives me, again, he's roughly 3 hours. So he's going to have 3 hours of his journey in his local time and then 9 hours backwards. So what I'm saying here is he's leaving at Monday at 5 p.m. He's going to take 3 hours to get to the international date line. Monday at 5 p.m, 6 p.m, 7 p.m, 8 p.m. Monday at 8 p.m. So he's going to get here Monday at 8 p.m. But as soon as he touches that international date line, he's then going to go Sunday at 8 p.m. So that's Sunday at 8 p.m, but he's only flown for 3 hours. He's got another 9 hours to go. So Sunday at 8 p.m, 8, 9, 10, 11, 12, 1, 2, 3, 4, 5 a.m. So he's going to arrive on Monday at 5 a.m. So he's going to be Monday at 5 a.m. And then Michael, I've got, what did I say? Monday at 11 p.m. So now we just got to work out Josh, because he's flying from Auckland. All right, okay. So again, Josh is pretty much on the international date line. So he's leaving Monday at 10 a.m. and he's going to be flying for 5 hours. So 10, 11, 12, 1, 2, 3. Monday, 3 p.m. Monday, 3 p.m. But we've got to go backwards because of the international date line. So we're going to knock a day off of that. So Monday at 3 p.m. is going to be Sunday at 3 p.m. So Sunday at 3 p.m. Now, having got those, that would suggest that Sunday at 3 p.m. So what does it say? From the first to arrive to the latest. That means that Josh is going to be first, then Harry, and then Michael. So Josh, Harry, Michael. I'm going to go for E as my correct answer. Okay, Module 4, Graphs and Relations. Let's go. Use the following information for questions 1 and 2. The distance time graph shows a man's train journey between two towns. The train leaves the first town at 11 a.m. and arrives at the second town at 2 p.m. Thank you very much. The average speed of the train for the entire journey. Well, the average speed, I remember, is total distance travelled divided by total time taken. Right, the total distance travelled we know is 180 kilometres. How do we know that? Because if I look at this point here, it comes to here, so it's 180 kilometres. And the total time taken in hours is going to be 1, 2, 3 hours. So if I do 180 divided by 3, it gives me 60. So average speed of 60 kilometres per hour. For how many minutes was the train stationary during the journey? Well, the stationary bits are these horizontal bits. That basically means it's not covering any distance. So here, that is 30 minutes. No, it actually isn't. And again, always make sure you read the scale properly. That is 15 minutes. And here, that is 30 minutes from 12:45 to 1:15. So total number of minutes in stationary would be 45 minutes. The graph below shows a straight line that passes through the points 6, 18 and 10, 22. The coordinates of the point where the line crosses the y-axis are. Again, there's probably lots and lots of ways of doing this. What am I going to use? I am going to use y equals mx plus c. Let's do that one. I don't normally use y equals mx plus c, but I'm going to use that for my gradient. So I know it starts at 6 and goes to 10. So it has a horizontal distance of 4. It goes 18 to 22, which is a vertical distance of 4. And so the gradient of that is equal to 4 on 4, which is 1. So y equals mx plus c. Actually, I'm going to do that and then show you another way of doing it. So let's choose a y coordinate. Let's choose 6, 18. So 18 is equal to 1 times the x coordinate of 6 plus the value of c. So that's 18 is equal to 6 plus c. So c would equal to 12. So that's basically my intercept. So my coordinate would be 0, 12, which would be b as my answer. Another way of doing it, once I know what the gradient is, I know that for every 1 backwards, it's going 1 down. So that basically means, remember, so for every 1 down, it's going 1 backwards. And because to go from 6 to 0 is going to move 6 horizontal, it must mean that it's also moved 6 down. So again, 18 minus 6 would give me the 12. Just a different way of thinking about the question. The graph below shows the cost in dollars of sending a package by a courier based on the weight of the package in kilograms step graph. Gloria has to send 3 packages to 3 different destinations. One package containing 1.5 kilos, so that's going to put me here. One package containing one weighing 2 kilos, which is going to put me here. And one package weighing 4.5, which is going to put me here. The total cost of sending those packages is okie dokie. So now I'm going to zoom in and make sure I actually read this properly, because I always misread these diagrams. 13, 15, 16, 17, 18, and 24. So those are my costs for those individual step graph bits. And so if I now do 13, 18, and 24, and again, there's nothing wrong with using my calculator, just so that I don't make a stupid mistake, would be E, $55. Wong's dishwasher repair business repairs dishwashers in owners' homes. It takes 45 minutes to repair a dishwasher. If it takes 45 minutes to repair a dishwasher, the cost is $155. If it takes 2 hours to repair a dishwasher, the cost is $330. The rule of the cost of repair is that where A is the fixed fee for coming to the owner's home, B is the charge in dollars for each 15 minutes unit of time to repair the dishwasher, and N is the number of 15-minute intervals required to repair the dishwasher. B is the charge in dollars, and N is the number of minutes. So if 50, I think the trick here is 15 minutes and 15 minutes. Using this rule, the cost for a 90-minute service is... All right, so let's go back and substitute in what we've got. So I'm going to come up with two equations here. So looking at this first one here, we know that $155 is equal to the fixed cost. We don't know what the fixed cost is, but we're going to actually try and find it. So let's call that A plus B times N. So what do we say? B is the charge in dollars for each 15 minutes unit of time. Well, we also don't know what the charge is for each 15-minute unit of time. So we're going to find B. And we're going to multiply that by N is the number of 15-minute intervals. Well, because it takes 45 minutes, there's 3 15-minute intervals. So there's one of my equations. The next one is 330 is equal to A plus B. Again, we don't know those values for this, but we know that it takes 2 hours to repair. Now, how many 15 minutes are in 2 hours? It's 8. So I have 2 equations. What am I going to do? Oh yeah, I'm going to fire up my calculator and I'm going to get it to solve it. So solve system of equations, linear equations. How many equations? 2. I'm going to do A, comma, and B there, just so I don't confuse myself. And let's put in my 2 equations. So 155 equals A plus 3B. And the next one gives me 330 is equal to A plus 8B, if I remember rightly. Yep. Hit enter, and there we go. Now, if you've got some really funky answers there, then the chances are you're wrong. So what we now know is A is equal to 50 and B is equal to 35. So A is the fixed charge and B is that cost. Now what do we want to do? Using this rule, the total cost for a 90-minute service would be, so now we're going to work out the cost is equal to A, which is 50, plus B, which is 35, times 90 minutes. Well, how many 15s are in 90? That will be 6. Let's just check. 15 and 15 is 30, 60, 90. All right, yep, that's it. So now 50 plus 35 times 6 gives me $260, which gives me D as my correct answer. The feasible region defined by 4 inequalities is shaded on the graph below. Moving up, one of the inequalities used to define this feasible region is. So while we can discount this one straight away, the reason being is we've got 2 vertical lines. They're not y equals lines, they're x equals lines. So actually those 2 lines there would actually be 4 is less than or equal to x is less than or equal to 6. So that's no good. Then I'm just going to work my way through each of these. So I've got 2x plus y is greater than or equal to 8. So y is less than or equal to minus 2x plus 8. Now I can automatically discount this one because none of those lines there have an y intercept of 8. So that one there is automatically off the cards. And I'm just going to test the next one, same thing. So we've got x plus 2y is greater than or equal to 8. So 2y is greater than or equal to minus x plus 8, and I'm going to divide both sides by 2 to give me minus a half x plus 4. Oh, hold on a moment, that is certainly there. So there is a line there with an intercept of 4. Does that have a gradient of minus a half? Well, the line is sloping down, so yes, that's negative. My rise is 4 and my run is 8. So there we go. So that's a contender. But because it's an inequality, we've got to test to see whether actually it is working the right way. So how do we do this? I test a point. So we've got x equals 5 and y equals 2. So when I substitute this in, that gives me 2 is greater than or equal to. Now I've already put 5 into my calculator there, so you can see that there. So I've done minus a half times by 5 plus 2, which gives me minus 0.5. So the value is 2 greater than or equal to negative 0.5. It is. So I'm going to posit that B is my correct answer. All right, happy with that? I'm just going to check E. The reason being is D and B are the same equation, but the inequality is flipped. So let's just have a look here at 2x minus y is greater than or equal to 8. So that's going to give me 2x minus 8 is greater than or equal to y. I've just swapped those around. And again, that can't be true because I don't have an intercept of negative 8. So it can't be that one. And I'm fairly sure then it isn't going to be D, because if I have my equation of y is less than or equal to minus a half x plus 4, which is what we had before. So again, my y value there would be 2 less than or equal to negative 0.5. Is 2 less than minus a half? No, it isn't. So D isn't and B is. Question 7. A 1,200 litre tank is being emptied by 2 pumps. After P minutes, when 800 litres has been removed, one of the pumps stops working. Okay, the graph shows below shows the volume of liquid V litres in the tank at T minutes. Thank you very much. Okie dokie. 1,200 litres, right. P, after P minutes. So I'm just going to write P here. Have a P, please, Bob. That's, doesn't matter what that means. Stop working. The graph below shows the volume of liquid V litres in the tank at T minutes. The tank is empty after 29 minutes. Okay. If both pumps had continued to work, the tank would have emptied in 24 minutes. So what that means is, if that had continued like that, this point there would have been 24. How is that going to help me? It's going to give me the rate of emptying so that I can then work out later on. Over the time interval from P to 29 minutes, the rate at which the tank is being emptied in litres per minute is closest to. Okay, how are we going to work this out? Well, I need to find out the value of P first. How do I do that? Well, I now have a gradient. So when I actually know the gradient of this particular section here, that will tell me the rate at which it's being emptied. Yeah, it also tells me how much, actually, I'll show you, yeah. So my gradient there is going to be given by rise is 1200 and run is going to be 24. All right. Now, again, this is going to be negative. So my gradient there is going to be equal to minus 1200 on 24. So when I do 1200 divided by 24, oh yeah. So when I do 1200 divided by 24, I get 50. So that's being emptied at 50 litres per minute, right? So litres per minute. How is that useful to me? Because I can now work out the value of P. I can work out, well, bearing in mind we've now here got rid of 800 litres. So 800 litres, 800 divided by 50, which gives me 16 minutes. All right, so now we know the value of P is 16 minutes. How is that helpful to me? Well, I can now find the gradient of this part of my line, which is effectively the rate of it being emptied, because I now know that the horizontal distance here is going to go from 16 to 29, which is 13. And I'm just going to do the thick Yep, sorry, try that one again. Yep, 29 minus 16 gives me 13. And I know that that is going to be 400. All right, so now let's do that. That's if I do 400 divided by 13 gives me 30.7692. So that's going to be around 30.7692 litres per minute. So that is the rate, and it wants it to be closest to, which is going to give me 31. Question number 8, the feasible region for a linear programming problem is shaded on the graph below. All right, thank you very much. The coordinates of the points that define the boundaries of the feasible region are P, Q, R, S, and T. Okay, thank you very much. We're maximizing the objective function Z equals ax plus by, where a is greater than 0 and b is greater than 0 for these constraints. The solution is found at point R only. That's important. The values of a and b for this objective function could be, all right, for it to be at R only, it means that my objective function touches that line there and only that point there. So what that now means is it cannot have a gradient equal to that line there, because if it had a gradient equal to that line there, there'd be lots of points along there that would fit my objective function, all right? So that's no good, so it can't have that be on that line there, and effectively it can't be on that line there, or it can't be on that line there. So basically what we've got to now have is we've got to have a value of this gradient that does not have an objective function here, or let's see, here, right? So it cannot have a value of gradient that is equal to those two, but it can have a value of gradient between those two. So what I'm now going to do is I'm going to find the value of the gradient of that line there, right? Because we know then that we can use that to help us with our objective function. So we know the gradient of that line there is 3 on 9. So that's 3 on 9, or minus 3 on 9. So the gradient there is minus 3 on 9, which is equal to minus 1/3. That value is going to become important. So what else? So this line here. So now we're going to find the gradient of the line going through R and S, which is that line there. Now again, that's actually easier to do because it starts at 8, or the intercepts on both the x and y axis at 8, so that means it has a gradient of 1, but because it's sloping down, it's going to be -1. So that line there has m is equal to -1. So what we now need to do is make sure that our objective function, our z, has to have a gradient that falls between -1 and -1/3. How do we do that? Well, I always take my objective function, ax plus by, and I rearrange it into an equation y equals mx plus c. So what am I going to get there? I'm going to get by is equal to minus ax plus z. Okay, minus ax plus z. Divide both sides by b gives me minus a on bx plus z on b. Now I'm not interested in this z on b business, but I'm very interested in this value here. So we now know for that objective function, the gradient is going to be given by the minus of a divided by b. And they've given me values of a and b here. So for this one here, we know that the value of that gradient, that objective function there, would actually be -1. Well, that's no use to me. Remember, we've got to find a gradient that falls between -1 and -1/3. So we're looking for values that fall between -1 and -1/3. Other than that, we can't have it. So that's no good, can't have A. What about B? Well, that's going to give me -1/3. So if I have B now with my A and B value, that's going to give me -1/3. Useful to me? Actually, I'm going to just change that because people will be screaming at me. It's got to be less than or equal. It's got to be less than or greater than. It's got to be between. It can't even be on those values. -1/3, no good to me. A and B. So this value here would be -2/3. Would that fit? Well, -2/3 does fit between -1 and -1/3. So I'm going to put a circle around there for the moment. It's feeling right. Let's do this one. D would be -3 on 1, which would be -3, definitely not. And A would be -3 on 2, which is -1.5. Again, that wouldn't fit, no. So as far as I'm concerned there, the correct answer would be C.